Hey, good morning, everybody. This is Mr. Ainsworth, and we're going to get into lesson 5 here in Unit 4 in AP Pre-Calc. We're going to look at exponential functions and try to match them with your graph. Okay, so in this lesson here, we've got a bunch of functions. We've got 15 of them, and they're all different types with different bases and different exponents and such. And what we want to do is match these with these corresponding graphs. How do we do that? Well, we look at the base, which is your common ratio, see if it's less than or greater than 1, and we look at other factors and we evaluate the function at different points. So remember these three things. So let's go to the top here and write a few things down. Okay, we want to look at the base or the common ratio first. Okay, so let's put this big and bold here. So we want to look, okay, at the base, which is your common ratio. So at the top here, let's write down the two types of exponential functions that we are looking at when we're talking about geometric sequences. As a function, it is y is equal to a times b to the x power, where a is your initial value and b is your growth rate or decay rate, okay? Or in sequence notation, it's a sub n is equal to a sub 1 times r, right, to the n minus 1 power. And we talked about this many times, that you could write this in terms of a sub 1 or any other term you want, okay? But the base here, okay, is your growth or decay rate, growth or decay rate, and this will give you a clue of what it looks like. And R in sequent notation is your common ratio. These are the same thing. Okay, common ratio. If the common ratio, if R is less than 1, we have decay, and it looks like a certain way. Okay, now if R is bigger than 1, or if the base is bigger than 1, like 1.5 or 2 or 3 or something, you have a growth function. And as you guys know, decay functions look like this right through here, and growth functions look like this, just as a general rule. Okay, so you want to look at the base. That'll tell you a lot about the function. Second thing you want to do is you want to evaluate the function. So evaluate the function, okay, at a few points, specifically at x equals -1, 0, and 1, and that will determine what graph you have. Some of these graphs, as you can see right here, look very, very similar. Like, for example, A and G, okay, they're both growth functions, but they hit the x-axis, or excuse me, the y-axis, the y-intercept at different points, right? So you want to evaluate the function at different points so you can differentiate between A and G, okay? Or like B and C, they're both decay functions, but notice that they contain different points. They have a slightly different curvature. So how do you tell? Well, you evaluate the function. All right, so that's the second thing we need to do. We need to evaluate the function at -1, 0, and 1, which shouldn't be that hard to do. And the next thing you need to do is look for reflections and shifts. Okay, so look for reflections, okay, and shifts. And that comes from the prior unit, unit 3, okay? So we know something about that, reflections and shifts. All right, so keep those things in mind as we go through the activity. All right, so here we go. All right, so what I'm going to do is first is take a look at the base and the common ratio and to analyze it here. So here we go. So on this one here, notice we have the common ratio, or the base is 1/2. So I'm going to just note that. Okay, R is 1/2. That's less than 1. And we have a decay function. So you do some analysis right through here. Okay, so it kind of looks like this. Okay, somehow. But where? Where does it intersect the x-axis? Excuse me, y-axis. What's the y-intercept? So we need to evaluate it. Okay, so if you put 0 in the function here, if x equals 0, right, and you can do your work in your head or you can do it on the side, but 1/2 raised to the 0 power is 1. It's called the 0 power rule, and that's called your y-intercept. All right, but that's not enough. We need a few other points. Like I was saying, you have to differentiate it from the other ones that look like decay graphs. So let's evaluate it at -1. Well, negative or 1/2 to the -1 power means you got to reciprocate the 1/2 to get 2. Okay, so -1 comma 2 is on the graph, and then we're going to evaluate it at 1, and 1/2 to the first power is obviously 1/2. So we have 3 points on the graph, and now we go fishing, okay, or hunting. All right, we have to look for this, and keep in mind, look for the y-intercept here at 0, 1, and then look at -1 comma 2. Okay, so let me see. So B and C both have a same y-intercept. Okay, so this one's at 0, 1, and this one's also at 0, comma 1. They look similar, but they're slightly different. This graph B here intersects at -1, comma 4, and over here intersects at -1, comma 2. Now, which one do we want? Well, take a look at it. We want it to go through -1, comma 2. All right, so this has got to be graph C. Okay, so this is y equals 1/2 to the x power right through here. So let's make a note of that. So this one up here is C. Now on to the left here, so C, you can write it over here. So y is equal to 1/2 to the x power. Is it increasing or decreasing? Well, it's a decay graph. So if you take a look at here, it's decreasing. It's going down. It's decreasing, right? And guess what? It's concave up, right? It's concave up. So we make a note of that. So it's decreasing, okay? And it's concave up, CC up, okay? Or you can use any kind of notation. So CC and then up, however you want to write it. We've been doing this for a long time because we learned about concavity earlier in the year as we were talking about functions, right? And that's how the game is played. All right, so let's go through a few more here since you're probably at home, since you're watching this video. If you're with me in class, we'd be doing this together in groups, all right? Where I model a little bit, but then I set you guys up into the main groups and you guys actually work together in pairs. Oh, not pairs, but groups of 3s and 4s. Okay, now here the base is 3. So base is 3 or r is equal to 3. That means it's growth because it is greater than 1, and it kind of looks like this. Shoots way up. All right. When the base is 3, my God, they triple. This is tripling, and when things triple, they get big really, really fast. All right. And so this graph is very steep. Growth. All right. So some points, though. So -1. Let's start at -1. Because again, look at my little things to remember here. Okay. You want to evaluate it -1, 0, and 1 every single time. All right. So let's do that. So -3 to -1 power is 1/3. Okay, so 3 to -1 power is 1/3. You reciprocate the base. That's what the negative exponent means. It does not mean that the number is negative. You know, that's the very first misconception people have when they see negative exponents when in algebra 2. Well, actually, I teach this stuff in algebra 1. So you have to get fluent at that. You have to get good at it. Now at 0, where's the y-intercept? So 3 to the 0 power is 1. And then obviously, if you substitute 1 in there, 3 to the first power is obviously 3. So, all right, so we're looking for growth functions, and we're looking for a y-intercept at 1 or at -1, comma 1/3. So here we go. Growth functions. Well, A is a growth function, and it has a y-intercept of 0, comma 1. But at -1, we don't know exactly if this is -1, comma 1/3. Kind of looks like -1, comma 1/2. Okay, so -1, comma, oops, 1/2 here. That's what it kind of looks like right there. We do also know that it passes through 1, comma 2. So going back up here, our function has to go through 1, comma 3, and obviously graph 8 does not do that. So let's go find some other growth functions. Okay, so G, well, we have some choices here. So G doesn't go through 0, 1, and so this one, this could be 0, comma 1/2 maybe, 0, comma 1/2. And the other one here, The other point that it goes through is obviously 1 comma 1. 1 comma 1. Okay, so in this graph here goes through 0 comma 3. So you got to find some other ones here. So, oh, look at graph I, that's growth too. It goes to the origin. So where is it? What am I looking for? Now I lost track. So I'm looking for 1 comma 1. Oh, 1 comma 3. We found it. There we go. Where was it? Where's my growth? Oh, here it is. F. All right, so it goes through 1 comma 3. And it also goes through 0, 1. And let me see down here. Ooh, see it's less than halfway. So that is negative 1 comma 1/3. Look at that. Okay, so this is y is equal to 3 to the x power. This is growth. All right, why? Because r is greater than 1. It increases very quickly. And that's how the game is played, my friends. All right, so let me see. So f is 3 to the x power. So let's record that. So y is equal to 3 to the x power. It's increasing because it's growth, right? And it's concave up. All right. Let me see. Let's try another one. Obviously, I'm not going in order here, but it doesn't really matter. Okay, so let's try number 11 here. I don't know why I was going out of order. I guess because I read from left to right. All right, so now notice here we're looking at reflections and shifts too as well. R is 2, all right, so it looks like a growth function, but guess what? We got a reflection. All right, so this right here, this is a reflection, reflect over the x-axis. Now, R is 2, this right here, R is equal to 2, which is greater than 1. So this is a reflection of a growth function. All right, so it's going to look a little bit different. So it's a reflection of a growth function. Reflection of a growth function. Growth function. Now, a growth function normally goes up, right? All right, but if you reflect it over the x-axis, now guess what? It's going to go down right there. So we got to be careful. We got to evaluate this guy. So let's evaluate it at -1 first. All right, so negative of 2 to the negative 1 power equals -2 or -1/2 because you got to reciprocate it. So -1/2. And then at 0, we have a -2 to the 0 power, which is -1. Right? 2 to the 0 power is 1, but you got to make it negative. And then you have to evaluate it at 1. So -2 to the first power. So well, guess what? That's just -2. All right. So we have some points on the graph. So we're looking for something that's, ooh, look at that, decreasing and concave down. And we also have to intersect the y-axis at 0 and -1. All right, so let's go hunting. 0 and -1. Here's one right here, graph D. So here, this is at 0, -1. Let me see, what points are we looking for? We get -1, -1/2. Oh, look at that. -1, -1/2. Right there. Okay, and also look here, 1, -2. Is that on the graph? Let's see. Yes, it is. Oh, so we found it. Okay, and that is graph, where'd it go? Graph D. Okay, so this is D right here. And let me see, 6, what was that? That was, well, where'd it go? Graph F, okay. So this one's F here. All right, so we found another one. Okay, so D is -2 to the x power. So y equals a -2 to the x power. Okay, it's decreasing. It's also concave down. All right, well, we're rocking and rolling. And this is how the game is played. All right, they're not all easy though, so let's go through a few more. This one's got some interesting things here. Okay, so here on number 2, 3 to the -x power here, We got to be careful a little bit here. It looks like a growth function, but you got to be careful. You got negative exponents. So here, be careful in this one. The base is 3. Okay, R is 3, but you got to... Sorry about that, guys. It's wake up time. But I was already awake, as you can tell. It's 5 a.m. in the morning, and Ainsworth is starting early. Uh, all right. So you have to rewrite this function here. When you have negative exponents, rewrite it because this is growth in disguise. So excuse me, decay in disguise. Decay, all right, in disguise. Ooh, what do I mean? Well, okay, so let's rewrite this. So y is equal to, I'm going to use, again, I'm going to use exponent laws here. So this is 3 to the negative 1 power raised to the x power. Okay, you have to remember in exponents that power to a power, you multiply exponents. Okay, power to a power, and you learn this in Algebra 1 here, you multiply exponents. Okay, so rewrite it. So negative 1 power raised to the x power is the negative x power. So I just rewrote it. And as you guys know, guess what? 3 to the negative 1 power is 1/3. Okay, so we have actually a decay function. So this is decay, all right? Why? Because r is equal to 1/3, which is less than 1. Now we need some points. All right, so let's substitute negative 1 in there. And 3 to the, or 1/3 to the negative 1 is 3. So it passes through negative 1 comma 3. Put 0 in there, you get 1. And then you put 1 in there. 3 to the negative 1 power is 1/3. Okay, so we know it's a decay function. And okay, so it's got to look something like this right here. Okay, so let's go fishing. All right, we're looking for negative 1 comma 3 on the graph, and it's decay, so it's going down. Okay, so well, let me see. So this one goes through 0, 1, and it also goes through negative 1 comma 3. What points am I looking for? Let's see here. So 1 comma negative 1. Oh, look at that. Negative 1 comma 3, 0, 1, 1 comma 1/3. So negative 1 comma, let me see, 1, oh yeah, 1 comma 1/3. There we go. 1 comma 1/3. So this is y is equal to 3 to the negative x power, which can be rewritten as 1/3 to the x power. All right, so this is decay function. All right, so you can't just look at the base and not the exponent. This is a one to study, all right, because this one gets a lot of people. People just look at the base and go, oh, it's growth, right? But it's not. It's got a negative exponents, so it changes things. It's actually a reflection over the y-axis. So let me make a note of that. So this right here makes the original function 3 to the x, okay, reflect over the y-axis. All right, so normally this function would be doing this, okay, like this, all right, and it would pass through here, but you got to reflect it. Okay, so it's a reflection. So this is 3 to the x power, which is growth, but when you have a negative exponent, it reflects it over the y-axis, right? So this is a reflection. Okay, I'm talking about over the y-axis, not the x-axis, because you're affecting x, not y. Okay, and that is a good one. So E is 3 to the negative x power. So let's record that. So y equals 3 to the negative x power. All right, it is a decay function, so it's decreasing, and it's concave up. All right. Oh, let me check D. D is, ooh, that's concave down. D is concave down. So let me fix that. There we go. All right, I'm not going to go through all of these in this video here, but I will go through a few more. just for funsies. All right, so because you guys need some experience, let's just kind of play around with it here. All right, so let's take a look one with a shift. All right, like number 3. Let's go do number 3. All right, so here the r is 2, it's greater than 1. So, and we don't have a negative exponent, so this is growth. All right, but this right here, this is an upshift. Okay, so, oh, excuse me, down, sorry, down 1. So this has been shifted down 1. So it's a shift down 1. We learned about that in the unit 3. Okay, so we're looking for a growth function, and now we need to put some values in there. All right, so 2 to the negative 1 power minus 1 is the same as 1/2 minus 1, or negative 1/2. Okay, next point, put a 0 in there. So we have 2 to the 0 power. So 2 to the 0 power minus 1. 1 minus 1 is 0. So it's got to go through the origin. And then you got to put negative 1 in there. So 2 to negative 1 power minus 1 is 1/2 minus 1. Or excuse me, yeah. Oh, I already put that in there. Oh, no wonder. It's early, guys. Sorry. I want to put in positive 1. All right, so let me redo that, because I already did that. Okay, so 2 to the first minus 1, well, that's 1. So here we go. So we're looking for something that goes to the origin, and it's going up, okay? And it also goes through 1 comma 1. So we're looking for growth now, okay? Okay, so here we go. So here we go on this one. It goes through the origin, so 0 comma 0, goes through 1 comma 1. So a normal growth function, 2 to the x growth function, would go through y-intercept at 1. But this whole thing's shifted down, as I was saying. All right, so here 2 to the x, and I'll draw it for you just for funsies here. 2 to the x would go through 0, 1, and 1 comma 2. So it would look like this. And then 2 comma 4. Okay, so there's 2 to the x power, but it's been translated down or shifted down, see? So the one in red here, y is equal to 2 to the x power minus 1, it's growth, okay, they're both growth, all right, but it's been shifted down, right, okay, down 1. All right, there we go. And so that's I, so 2 to the x minus 1 is I, so let's record that. So y is equal to 2 to the x power minus 1. It's increasing because it's growth, all right, and it's concave up. And that's how the game is played. Let's do something different here. Let's do number 5. Okay, again, because this uses exponent rules, so I'll do the tough ones or the tricky ones. Okay, so now remember what I said earlier. It looks like the base is 8, but it's got a different exponent. Okay, so you want to go power to power. So y is equal to 8 to the 1/3 power raised to the x power. Again, remember what I said earlier, power to power, you multiply exponents. So when it comes to exponential functions, you have to remember everything from algebra 1. Okay, now 8 to the 1/3 power is 2. Okay, it's called the cube root. Oops. Oh, come on, Ainsworth. Cube root, okay, of 8, and that is 2. Okay, 8 to the 1/3 power is the same thing as a cube root. Why is it 2? Well, 2 to the 3rd power equals 8. Okay, that's why. Okay, so now this is equal to 2 to the power of x. And guess what? I think we already did that one. Did we? Not yet. Okay, it's number 7. Okay, so this one here is the same as number 7. It's in disguise, okay? Now the base is 2, which is greater than 1, so it's growth. Okay, we need some points though. So -1, you substitute -1 in there, you get 1/2. You substitute 0 in there, you get 1, and then you substitute 1 in there, you get 2. Okay, so let's find 2 to the x power. 2 to the x power growth function. Okay, so what is it? It could be, let's see. Can't be g, because it has to go through 0, 1. Can't be L because it goes through 0, 3, even though it's growth. Where in the world is it? Oh, here we go. It's graph A. So this is y is equal to 2 to the x power. Right there. Okay, or y is equal to 8, right, to the 1/3 x power. It's the same thing. All right, there's our growth function. All right, so let's see here. Let's go ahead and record that one too. So that is A. So y is equal to 2 to the x, and y is equal to 8 to the 1/3 x power. Okay, it's increasing because it's growth, and it's concave up. There we go. All right, and let's do another one. Let's do 15. All right, for funsies here. Again, because again, these are it looks like growth function, but we got a negative exponent, so we got to be very careful here. All right, so we're going to rewrite this one. So y is equal to 16 to the -2 power raised to the x power. Okay, gotta be careful. Okay, now we need to rewrite it again. So y is equal to 1 divided by 16 squared, because it has a negative exponent right there, to the x power. And y is equal to, let me see, 16 times 16 is 256. 256 raised to the x power. So this is a decay function. So it's a decay function in disguise because of the negative exponent. Okay, and now we need some ordered pairs. So -1, comma something. You put -1 in there, it's going to reciprocate it to get 256. Holy cow. And then you put 0 in there. You get 1, and you put 1 in there. You get 1 over 256 to the first power. You get 1, 256. So it's very close. It's a very small number. Okay, and it is a decay function, so it goes down like this. Okay, so let's figure this out here. Where is it? Okay, so it's got to go through 0, 1 and 1 comma 256. Holy cow. So decay. Let's look over here. Where is it? Okay. It's not on here. Where is it? It's not on here. Check it out. Well, that can happen. Oh, you know what? Check it out. So there's 15 functions. And I guess, some have multiple representations. We've got 12 graphs, 15 functions. And this is, I don't see it on here, guys. All right, I don't see a decay function that passes through 0, 1 and 1 comma 1 over 256. Holy cow. I mean, graph B kind of looks like it, but let me see, -1, -1 comma 256. Holy cow, that's way up there. It's very steep going to the left, and I do not see that. Okay, so it's not on there. All right, so let's do, what the heck, we can't end like that. So let's do number 14. All right, so, oh, there's another exponent rule. So Here we go. So this one, let's rewrite it here. So 2 to the x power, we're going to split it. All right, split using exponent rules. All right, times 2 to the negative 1 power. I talked about this in class, okay? When you multiply like variables, you add exponents. So if you combine these, 2 to the x times 2 to the negative 1, you get 2 to the x plus 1, or x plus negative 1, which is the same thing as 2 to the x minus 1. Now, 2 to the negative 1 power is 1/2. So this gives you 2 to the x power times 1/2. And rewrite that, just bring this in front. So it's 1/2 times 2 to the x power. All right, so this right here, this 1/2, when you multiply something by 1/2, this is a vertical shrink. Why? Because it's 1/2, it's less than 1. And then we got a base of 2, so r is 2. So we have growth. But it's not going to be as steep as 2 to the x power. All right, because the y values are being multiplied by 1/2. So let's pick some values here. So negative 1. So substitute negative 1 in there, and 2 to the negative 1 minus 1 is 2 to the negative 2 power, or 1/4. Put 0 in there, you get 2 to the 0 minus 1, which is 2 to the negative 1 power, or 1/2. And then you put 1 in there, and you get, you get 1, right? 2 to the 0 power is 1. So we're looking for a y-intercept at 1/2, and we're looking for growth. Here we go. So this is y is equal to the 2 to the power of x minus 1, or you can rewrite it as 1/2 times 2 to the x power. And again, this is growth. It's concave up and increasing. Okay, so that's g. So y is equal to 2 to the x power, or x minus 1 power, or y is equal to 1/2 times 2 to the x power. It's increasing because it's growth and it's concave up. All right. And then, of course, you got to answer all these questions here. So how can you tell an equation whether the function models exponential growth or decay? You look at the base, right? You look at the base or the common ratio. It's the same thing. All right. If r is less than 1, you have decay. If r is greater than 1, you have growth. And the only thing you have to be careful is be careful with the negative exponent. So let's make a note over here. So be careful with negative exponents. Okay, always rewrite your function. Okay, and it says one extra equation card turned up that wasn't part of the original set. All right, which would that be, or which graph would this match with? How do you know? Well, let me see. If you rewrite this guy, so what do we have? We have y is equal to 2 to the negative 1 power raised to the x power. And this is just 1/2 to the x power. So this is a decay function in disguise, as I was talking about earlier. Okay, explain why it's possible that one graph could represent two equations. Okay, they can be manipulated using the exponent properties. Okay, so exponential functions can be manipulated. Okay, manipulated. All right, using exponent properties. All right. And again, I'm not going to go through every single one here, but you get the idea. Okay, you have to remember the three things that I said above. Okay, when it comes to exponential functions here. So this part is really important. All right, remember these three things. You always look at the base of the common ratio and see if it's growth or decay, but be careful of negative exponents. Evaluate the function at negative 1, 0, and 1 to match the graph, and also look for reflections and shifts. And that is the idea. All right, this is a big lesson here. Of course, you need to be in class, you need to do the check for understanding, and you need to be able to apply things. All right, and I'm not going to write down the learning targets because I've already went through everything through here. Uh, but you need to also get in class, okay? And that's where all the learning happens, okay? So hopefully that helped you there. We talked about the functions. We did a lot of work on the functions here, evaluating, analyzing, taking a look at the common ratio or the base. And then we matched it with a function here by matching the points with also the fact that it's uh, either growing or decaying, whether it's concave up or down. And that's how the game is played. So just work through it at your own pace, all right, and then get back into class as soon as possible. And I'll see you there. It's Mr. Ainsworth here. Hopefully that helped you out. Take care, and I'll see you soon.